Hi everyone, and thank you for joining us today with Schneider Electric in our webinar on EV. The webinar will cover what is e-mobility, what is currently happening in the EV market, what is accelerating, what is delaying the adoption of EV in the UK, including looking at the implications for supporting electrical distribution infrastructure. My name is Wiem Melki. I'm the marketing coordinator at Rexel. Our guest speaker from Schneider Electric is Maya Pan, e-mobility sales manager, who will be introducing herself shortly. Please note, this is a recorded webinar and will be available to watch on demand on our Rexel website. If you have any questions throughout the webinar, please feel free to pop them in the Q&A box, and we will answer them at the very end. Now passing over to you, Maya.
Thank you, Reid. Thank you everyone for joining today. And today we'll be talking about the e-mobility with wider topics like why, what, and how, which is like a very interesting questions. And my name is Maya Pum from e-mobility Schneider. So, yep. So this is my contact to my LinkedIn, and feel free to connect with me, and I will constantly to share any market insight and also for the Schneider latest products. So feel free, and if you have any questions in the future or you wanted to connect with us, this is my email address and my work phone number. Feel free to jot it down. I will just like leave it to a few seconds for you guys before I get started. Okay, cool. So today we will be covering the agendas like the market insights about the EV market and then the EV charging market. And also I will give you a really quick review about the Schneider's e-mobility solutions. And after that, we will be coming to our key highlights of today to tell you how to select a white product, because we can see that there is a lot of challenging and struggle to find a white product. And followed by that, we'll be coming with a Q&A sessions. If you have any questions, feel free to drop it in the chat box, and then we will go through that in the end. Before we move into the market insight, let's give you a quick review about what's inside in the EV, because in general, people would always ask, why wouldn't I get the maximum charging speed out of the charging stations? It is because the EV side has absolutely power to tell the charging stations how much energy it's going to provide. So first of all, that would be like having 4 major components inside the EV. The first of all is the motor, which is the one to keep the vehicle in genuine and keep the vehicle in moving. Another key component of the EV is the battery pack. So basically, the battery pack will be deciding how long the driving range will be. So in general, the bigger battery pack, the longer driving range will be. So in the market, we can see that the maximum driving range available would be up to 300 miles, or maybe some of the time, if you have a premium options, that you can see 400 miles for the battery range. And another key component inside the EV will be the onboard chargers, because this one will be acting like a converter to convert from AC current to DC current. So in the case that if you're using an AC charger, this component will be absolutely dividing how much power supply will be using up back to your battery pack. And we can see that 90% of the market, the onboard chargers have a limitation up to 3-phase 60 amps, which is limited to 11 kilowatt. So it comes to questions like, if you're using a 22 kilowatt AC chargers, and if your onboard chargers can only convert up to 11 kilowatt, that could be a limitations to that. However, if you're using a 7 kilowatt AC chargers, that wouldn't be a problem. The final component of the EV would be the charging inlets. So most of the time that you see 2 inlets in here, one for the AC chargers. It depends what kind of car that you're driving. Possibly that you can see either 5-pin for type 1 charging cable or 7-pin for the type 2 charging cable. And also all of the cars will have a DC charging inlet, which will be able for you to plug into the DC chargers. When it comes to the market insight, we can see that the EV absolutely is a trend in the future. However, the blockers for people to switch to the EV is the price. So we can see that the price of the EVs will be significantly dropped over the years. By 2025, the price of an EV will be slightly cheaper than the traditional diesel car, petrol car. And by 2030, the price will become more affordable. And in the UK, we have a target to be less zero by 2050. So on the right side that you can see a diagram to see how much data for the sales of the EV compared to the traditional car. So as you can see from here, by 2030, around 50% of the car sales, whether it's first market or second-hand market, it will be EV or either in plug-in hybrid. And also just an update to you guys is that like by 2030 in the UK, there is a new sales ban. So in general, there will be no more petrol car or diesel car to be able to sell in the new car market. So once the price of the EV has been solved, another question that people will come in mind is that where am I going to charge my vehicle? So for the infrastructures, there has two applications, whether you can install at your home. Most of the time, people will prefer to charge it at home because they can overnight charge it and then they can continue the journey the next day. However, there is some limitation in the UK. For example, if you're living in an apartment, or if you don't own a driveway yourself, or even you don't have significant or enough power to supply. So in that case, you couldn't install home chargers. So if you wanted to switch to the EV, another option for you is to use the public chargers. So here is some data for you. Last year, we can see that there are over 30K of the public chargers available. And by 2030, the UK government and the industries, they are committed to install 300K of the public chargers. So as you can see, there has to be a charger nearby, whether if you cannot charge it at your home. And also the government have different funding model to support you. For example, the workplace charging scheme, the home charging scheme, and also the other funding framework model to support you guys. And for Schneider, we wanted to share the same vision for the UK government. So we wanted to make sure that the EVs are decided to charge when they stop, but not to stop when they wanted to charge. So it has to be an EV nearby. The accessibility has to be really easy for you to get access to. Another major blocker would be the electricity, because we can see that 98% of the EV chargers will be installed in buildings, in fleets, at homes. However, for the existing buildings, when they were built 50 years ago, 100 years ago, they were not designed to have this kind of capacity for the EV charging infrastructures. So we can see that the major blocker for the building owners, in order to install the chargers, they have to consider at least to increase up to 45% of their electricity consumption. So the cost for the infrastructures and the time to upgrade with the DNOs could be quite time consuming. So for Schneider, we do have an alternative solutions for you, which is using the load management system technology to optimize the building energy. Let's talk about what we can offer from Schneider. Before that, we wanted to share a message to you. The e-mobility is so much more than just the EV chargers. As you can see from this little iceberg, so this is completely on cost-effective perspective as well. Around like 47% of the cost, tenders possibly, they would go to the EV chargers, purchasing from distribution channel or purchase direct from us. However, what you can't see is that like over 50% of the cost goes to the consultancy services, whether to pay for the M&E design or consultancy firm to decide the wiring and decide what kind of system to be used in order to increase or upgrade the infrastructures. And also to upgrade the power infrastructures, for example, low voltage switchgear, feeder pillar, MV metering, etc. And for the operational side, the facility manager possibly have a proper service contract with us so that they can maintain the charges to be upgraded and uptime 99%. And also in order to monitor, in order to operate the charger itself, and then they would need to subscribe to a software services, which will be providing user management, building management, assets management, etc. Those kind of costs are a hidden cost. And in this way, what Schneider can do is that we can provide an end-to-end solutions to you. So before we're talking about the end-to-end solutions, we wanted to adjust that as a Schneider solutions. We wanted to focus on the commercial EV chargers because we can see that 80% of the market, they are located in buildings and in fields. So we can further divide it into different categories. For example, within the buildings, there are applications like residentials for those who wanted to install the chargers at their apartment, because there is also a regulations called document S. So at least 10% of the parking base, they has to be installed EV chargers. So this kind of application would be quite perfect case for the commercial EV chargers. And also we wanted to target the commercial charging space, for example, the destination charging spots, where you can actually see or find from the retail park, from hotel, or from university, places like that. And also the commercial chargers will be absolutely perfect for workplaces and fleet depots. So we have included a Q&A session in the end. However, we have selected the 5 frequent asked questions so that it will absolutely help you next time when you're deciding what kind of product that you wanted to need or you wanted to install for your project. So the most frequent asked question is that, like, should I choose a home charger for commercial use? Because we can see that there are many options available in the market, and most of the time that they are home chargers. So what is the difference between home chargers and commercial chargers? I have included some of the criteria for your general idea next time when you're selecting which chargers that you should put in your applications. The first factor will be the charging speed. For home charger, it is decided to install at your home, and most of the time the home will provide single phase power supply. However, for the commercial chargers, it will require more faster charging speed. That's why we will recommend to install 7 kilowatt or maybe even up to 22 kilowatt AC chargers. For the accessibility, the home charger, again, they are targeting the single homeowner. Whoever owns the driveway themselves, they will install chargers, and then the chargers will be only used by them, a group of people under the same single house. However, when it comes to the commercial chargers, the accessibility could be a way more complex because the charger itself has to be comparable to be used either in private charging points or in public charging points. For example, in private charging points, it could be in the workplaces. The chargers could be accessed by its employees or its visitors, or maybe some of the application will be installed chargers at private residential areas. So the question is, like, you have multiple users to use a single charging point. How can you manage that? So this is the questions about the cybersecurity. What kind of authentication method that you're going to be needed, whether it's using an RFID card or mobile apps. So these kind of questions has to be compatible with the chargers to make sure that your chargers are protected as a property. And for the security part, when it comes to the public charging sites, it requires a lot more cybersecurity or access security control. So the charger itself has to be OCPP 1.6 compliant, and also it has to be connected to back offices, which will provide another layer of this security for you, which I will talk about later in the application. Again, the home charger is for single purposes. So it either could be installed at your driveway, at your garage, or maybe if you have an off-street parking bay, you can install in that. And it's only accessible by dedicated users only. However, for the commercial chargers, the application could be quite multiple. For example, if you're putting a chargers in a workplaces, possibly in the same workplaces, you could install up to 10 chargers, and all of those chargers will be connected together, either to a back offices or to a node management system, let's say. And some of the applications, they will require to manage multiple sites, either to give them visibility about the energy consumption, about the user experience, and also the billing, how much revenue they're going to make from these charging sessions. And the next point is the infrastructures. For the home chargers, it's quite simple. All you need to do is to connect the chargers with your existing power supply. Possibly you also need to install LCD protection unit to comply with the IEC requirement. However, for the commercial charging sites, it is way more complex because, like I said, you do not just need to install one chargers. What you need from the power supply could be quite larger than a home charger. So you will need a proper design from the E&M or the consultancy, or maybe from Schneider, so that we can design the solutions for you to see how much power supply will be needed, which type of chargers will be the most suitable, and what kind of backend system or software system you're going to be needed in order to monitor and manage the power supply. For the connectivity, the home charger is quite simple again. Most of the home, they have their home Wi-Fi. And once you connect the chargers with your mobile apps, you can control when to start it, when to stop it. And some of the apps will give you visibility about how much energy you're going to be used or you have been used. And you can schedule what kind of time that you want to charge your chargers, whether within the light time, during the off-peak hour, where the tower scheme is so much cheaper. However, again, for the commercial chargers, because it involves a wider network with multiple charging points and multiple users involved, so it will require a more reliable network and system to make sure that the chargers are operating normally. And also, the commercial chargers will require a more complex smart functionalities, for example, roaming. So imagine that if you're a EV driver living in London, possibly you would download multiple mobile apps in order to use different chargers provided by different brand manufacturers. So in the case, that could be quite user unfriendly, right? However, with the roaming functions, we can connect all the chargers together with the CPO. So you just have to download one simple mobile app, and then you can get access to all of the chargers within your area. So this kind of like complex smart functionality will be required for the commercial chargers. The last point is the technical support. For the home chargers, the technical support could be quite simple because most of the time the manufacturer would include 2 years, 3 years of warranty. And if you have any problem with the chargers, just call them up and then they will arrange someone, an engineer, come up to replace the faulty unit with a spare part, maybe you clean up your chargers, etc., which is quite a simple job. However, for the commercial one, because most of the commercials are used by different users and you have no idea what kind of behavior they're using, whether they're going to use it brutally or they're going to use it gently. So not to speak about some of the chargers, they will require require a revenue stream. So they will bill the end user for X amount of the energies they have consumed. What I'm trying to say is that it will require a lot more compass for the technical support in order to ensure 99% uptime. And for Schneider, we do provide a service agreement with our customer because we can see that there are three major types of problem: the hardware problem, the software problem, and the network problem. However, with the proper service agreement, we can align every parties together to make sure that the chargers are working properly. Next question. Should I choose a 7 kilowatt or 22 kilowatt chargers? Which is another frequent asked questions. To make things simpler, I have categorized as two major factors. The first one would be based on how much electricity supply you're going to be having on site. In general, the more supply you have, the more voltage you're going to be recommended. Or if you have limited supply and you have just have 2 units, 3 units of chargers, the 7 kilowatt would be an ideal case for you. And another factor is the accessibility and applications. It depends who can get access to the chargers, whether it's for public users or private users, and where you're going to install chargers with. So let's take a look at the left side, which is like the blue one here. So for example, if you wanted to install the chargers at offices, workplaces, apartments, where people tend to stay there for 8 hours, 7 hours a day, we would recommend to install 7 kilowatt chargers because the average time to charge a vehicle from at least 20% to 80% or fully charged will be within 5 hours, 7 hours, or maybe maximum in 10 hours. Depends what kind of vehicle that you're driving. So in general, the 7 kilowatt will be efficient and sufficient enough for you to charge your vehicle if the application is offices and workplaces and they have dedicated users for that. However, if you're going to install chargers at more public area, for example, in council car parks, retail car parks, or maybe in a service station, railway stations, or maybe in restaurants, where the access to the users would be a public access. So you have no idea who is going to use it, and people tend to use the chargers within 4 hours, 5 hours maximum. So in that case, we will recommend to install higher speed of the chargers so that the one user, once they finish charging, they can leave the vehicle and let the other one to use it. So this is a general idea, depending the electricity supply and who is going to use it and how big or how wide of the accessibility will be. The third question is about the mid-meter. So what is the mid-meter? The mid-meter is required by law to install that only if you have intention or if you have planned to have a building options in the futures. Because the mid-meter will provide a higher accuracy on the energy measurements. So you have options to install the mid-meter either to be installed inside chargers, which this one from the picture that you can see, that we can either embed the MID meter inside chargers, or alternatively, you can install the MID meter in the MCB board. So either way it could work. About the LCD protection. So we can see that some of the manufacturers, they do not include that. Some of them, they do, like Schneider, we do. So as you can see, we have options to install the LCD inside chargers here, which is by IEC requirement. It is a must. and each individual protection, each individual charges has to require a individual protection. Either it has to be type A or type B. However, pay attention to that. If you are using a type A LCD, it has to have a conjunction with the LCD. So this is the Schneider chargers. The latest one we just launched it last year, EV Link Pro AC. In this one, we have already embedded the LCD 600 detection in here. So in the case, you can just install a LCD type A in here. Or again, you can install in upstream in the MCP board if you like it. Last question. This is the most interesting one, which is most of the buildings, they would ask about it because we can see 80% of our customers, they will require load management system because we can see upgrading the whole infrastructures to have 100% EV provision could be quite costly. So last question is like, what should I do if I have insufficient power supply? Like I said earlier, you have two options, either to upgrade the power infrastructures or alternatively to use the software. So this is a cost-effective options for you. Why is that? Because if you recall the messages that I sent earlier, at least 40% of the energy consumption will be required if you wanted to install the chargers at your building. So what happens if you don't have sufficient power? So here are the risks or hazards that you possibly will be facing. Possibly you'll be facing overloading if you're using more power, more than you subscribe to. And then probably you'll be facing penalties from the grid provider. And also, more importantly, you'll be paying more energy billing than what you expected. So the smart way is that we can use a node management system, the EV charging expert, to protect and prevent all of these questions that I've just mentioned about. So in the end, there will be no blackout, no penalties, and no increased billings for you. Cool. So this is a very brief, quick questions. Let's see if we have any questions from the chat box.
Thank you so much, Maya. That was so insightful. So we have a couple of comments from Robert. Actually, Robert mentions the cases of some fires that were triggered by batteries in certain buildings in London. So the dangers of batteries setting on fire in buildings. So what is your take on that? Also, he's mentioning some other challenges related to lack of availability of enough charging stations. Also queuing while waiting for the charging. He also had some suggestions about battery swaps, if it's an option in the future, if we think about the future, instead of charging, if there's an option of having a battery swap scheme. Also, yeah, so a couple of comments there, if you have any feedback or suggestions.
Cool. Thanks. First of all, thank you, Robert, for the questions and the suggestions. Let's go through the suggestion first. Battery swaps. This is a really good idea, and we can see that it has been really popular in the motorcycle market. So if you're driving an e-bike, which the battery pack would be so much smaller, I would say, which is size with your arms like that. So in the case that you can easily to charge your battery, and if the battery is out of juice, you can swap it with a new one, because the nature of the e-bike is smaller compared to EVs. So the battery swaps market in the e-bike market is already very popular. However, when it comes to EVs, whether it's like private cars or e-trucks, it could be a problem because we need a mechanics to swap the battery pack, which is like you have to open up the cars to do that. So we can see in the future that's possibly will be coming up in the future. So for the question one, the EV catch fire. So I think that could be possibly have few reasons. First of all, possibly they're using a 3-pin 60 amp 3-pin socket, which most of the time they're considered as a mode 1 charging, which in the US they have already planned to use that because they do not contain any LCD protection inside. So in the case that the vehicle itself will be charging overnight with 20 hours, 15 hours, maybe even more. So in the case that it will produce the hazards or risk of overheating. So in that case that the vehicle will be easy to catch fire. And another scenario I can think of, even though if you're using a Mode 3 EV chargers, some of the manufacturer or the other brands, they do not contain the LCD component inside the chargers, which is required by the IEC 61A requirement. And the LCD, the main job of the LCD is to detect the currency, AC current. And in the case that if the current over exceeds 40 amps, it will trip the unit. So there will be no more electrify to the users. However, if you're missing that protection, that could be a risk to catch a fire too. For the question two, if I recall correctly, is because of the lack of charging infrastructures in the UK. Yes, it is. We are working on it, and there is a still long way to go. However, we can see that different councils, they're working on it to increase more chargers in the public council car park, and also for the private sector like Schneider, we are part of the EV100 company. So we are installing more chargers in our workplaces to make sure that our employees can get access to charge the EV, and then also to encourage them to charge the EV wherever they wanted to. And we can see that in the motorway, every service stations, at least they do have the DC chargers for the long driving users. So even though that the numbers of the public chargers, they are not enough today, however, there has to be somewhere nearby where you live it. And yes, we do agree, is lack of EV chargers infrastructures. However, it's like egg and chicken questions. So whether you should install more chargers today, or maybe you should have more EVs today. So I think it's like a two-way direction. First question is killing. I'm not sure what that question is. Wait, can you like repeat that one?
Do you mean the one regarding not enough? I think you mentioned not enough charging places, the case of fires, and then the battery swap. Yeah, those were the main ones.
Okay, I think there is another question about queuing, if I remember correctly. Like queuing.
Yeah, Robert was mentioning like there was a lot of queuing because of the lack of enough charging stations, basically. So yeah, if there were any solutions.
Charge their vehicles. Possibly they're like forced to stay in the service stations overnight because the charging stations, they are occupied by the other people, so that they have to have another unexpected trip. Yeah, it happens sometimes.
Yeah. We had another question from Junaid. How many public EV chargers do you plan on installing in the UK?
So we do align with the government goals, which is by 2030, 300K more public chargers will be available. by then. And the public chargers will be including the AC chargers, will be seen in 7 kilowatt, 22 kilowatt, and also with the DC chargers infrastructures. And some of them will be providing like 30 kilowatt or maybe even up to 350. So all of this will be kind of as a public charging stations.
Actually, we had a question about DC chargers as well from Yuri Ben. He said, does Schneider manufacture this type?
We do have a DC chargers option. So at the moment, we have 24 kilowatt DC chargers available for the public charging sites. And in the future, that definitely will be in our roadmap to include more. So if they can leave that contact, we can give more insight and information to him.
Brilliant. Okay, I will take one more. We have quite a few questions. So say I am a pub chain owner. Do you have any solutions for installing EV charging across the state? And would you maintain it as well to provide EV charging for customers? From Junaid.
Blockchain, you mean, right?
Yes, yeah.
Okay, so good one. Haven't considered that one yet. Blockchain technology is a new thing, obviously. So basically, it's like a higher security to create a contract together to make sure all of this personal data will be secure in one place. So if another one wanted to get access to that, it has to lock the door, ask for permissions. So this is just another method for the authentication method. However, in the EV industries, it's already in the roadmap. So if you have heard of the OCPP 2.0, one of the functions will be including the plug and charge function. So the plug and charge function, so basically it's like once you plug in the charging cable in, and then there is a communications between the vehicle and the chargers. So the vehicle itself will communicate, I am vehicle 1234 and user ABCD, and then pub chain. So sorry, do you mean like pub for restaurant?
Yeah, I think, yeah.
Sorry, I misunderstood that. I was like talking about blockchain.
Yeah, no,
So
no worries.
No, it's like pub chains, like for restaurants, like pubs and bars. So can you like repeat the question again? Like what is our plans to install chargers in pub chains, right?
Yeah, so do you have any solutions for installing EV charging across the state? Would you maintain it as well to provide EV charging for the customers?
Cool, cool. So we have different solutions, including the pub chains, bars, and restaurants. So in the case that most of the restaurants, if they have sufficient power supply and if they have their own parking base for public use, for their visitors, for their owners, and etc., we do provide a 22 kilowatt AC chargers for them. So in the case that if they plan to have a dinner or lunch or a meal with 3 hours, 2 hours, with 22 kilowatt AC charging time, you can get up to 44 kilowatt, which approximately you will get to about 100 miles of the driving range. So that would be more than enough for them. And we do have a back offices connection. So in the case that if the pub chains or the bar owner, they wanted to connect to their points scheme or to their like promotional schemes, we can connect the chargers to a back offices. So in the case that if they have any promotions, they can push the messages through the mobile apps saying like, this weekend we have a promotions. If you charge at our pub at this location within certain amount of the time, you can get extra 5% off. All of these promotions and messages will be connected to our chargers. So it would also help the business to grow their revenue. Yep.
Yeah, thank you for that. So one final question from Yuri Ben. How is your load management works?
Good questions. Like I said, 80% of our customer, they are tied up with a load management system. In general, Schneider has been in the industry for 12 years, so we are a pioneer in terms of the load management system. In general, we do have two models, which is a static load management system, which we will be having a guaranteed minimum charging speed to each of the charging stations, depending how much energy or capacity the facility will be providing. Another model would be the dynamic load management system, which will require a energy meter to connect to the buildings. So with the dynamic ones, we can monitor how much loading the building is using. So if in the case that if the building's usage are lower level, the dynamic load management system will distribute more power back to the EV charging stations so that they can enjoy higher speed when they're charging their vehicles. So this is the two major roles. How do we use the load management system to control the charges and also to help the facility manager, the building owners to save their costs? Because when you compare to upgrade the whole power infrastructures and to buy a load management system, which is just like a mini server completely working on a local server basis, doesn't require any internet services, doesn't require any subscription fee in the future. You just have to pay for a one-time fee, and then you can have the load management system on site, on premises basis. And when it comes to the cost effective, it will be a good investment for the interim operational wise.
Yeah, that's all for now. And yeah, if you have any more questions, please feel free to reach out to Maya. Feel free to send us emails, marketing@rexel.co.uk. Thank you so much, Maya. It was super, super informative for the session today. Thank you everyone for joining us, and we'll keep you posted about more webinars with Schneider Electric. Thank you so much.
Thank you.